Good morning, students. This is going to be our lesson on the next 3 pages, which we'll be covering today, which is going to be lesson 26, 27, and 28. We are going to be doing some questions throughout, so please make sure you watch the video to the very end. So we're going to start with lesson number 26, which is called the coordinate system. This is similar as the idea as last time, where we're talking about how do we identify different coordinates on a graph. And we previously talked about ordered pairs, which has an input and output. But now we're moving on to coordinate pairs, which is x and y values. You'll see at the top I have an x comma y. That's how every single ordered pair is always written. X is always first and y is always second. Now, we should understand what is the x value. The x value is in relation to the origin, which is 0, 0, which is the middle point of the graph. Every graph will have an origin. That'll be like the place where the y and x-axis intersect. We want to understand what is the x value, and that is how many places to the right or to the left is the point. Okay, so our x-axis is always horizontal, left and right. Our y-axis is always vertical, which is up and down. Okay. When we have these types of questions, what we're trying to understand is how many times to the right or left do I have to find to get to my x value, and how many times up or down do I have to go to find my y value. Okay, so the number like 6, 4, 6, 4 would mean that I am 6 points to the right and 4 points up. Okay. Now, the x-axis is always going to be left, right. The y-axis is always up, down. And when I talk about the origin, what I'm saying is the central point of every graph is called the origin, and that is the value of 0, 0. Right? So that's the middle point of any graph. And then reviewing, horizontal lines are right to left, and vertical lines are up and down. Okay. If you sort of follow these ideas, you should be able to complete the coordinate system page, which is, let me look for a second, page 149, 50, and 151. For that page, what I'd like you to do is the following questions. We have page 149, and we will be doing number 1A, 2, 4, 5, 6, 7, and 10. Right, so page 149, those are the questions you should be doing. We're going to continue doing the next page because they all have a similar idea. Our next one's talking about horizontal and vertical distances. When we look at these two values, we can say, well, what's the distance between these two numbers, or these 2 points on a graph, right? Now, it depends on what we're paying attention to would tell us what the distance apart is, because we would want to understand, are we comparing x values or are we comparing y values? So if I start with the y values, because it's a little bit easier, that means what's the vertical distance between these 2 points? Well, actually, the vertical distance is 0. They're both on the exact same line. Now, if I were to say instead, what's my horizontal distance away from these 2 points, your best method would be doing a subtraction. So 8 subtract 3 would be 3 points. Or sorry, 5 points. That's not how it works. Yeah, 8 subtract 3 would equal 5 points. So my distance could be, if I'm paying attention to the x value or y value, my x value would be 5 units, or my y value would be 0 units. So I need to make sure I'm understanding what the difference between those two things are. Horizontal is my x values, and my vertical distance is my y values. If you do not remember that, or if you don't pay attention to that, you're going to have really interesting answers. Remember, x is always first, y is always second. And you wouldn't ever compare the x value to the y value. That just wouldn't really happen because they're on different axes. It's not really, it wouldn't make sense to do that. Okay. Now we're going to start coming into the integers idea again. Remember, an integer is either a positive number, a negative number, or the value of 0. But at the end of the day, they all must be whole numbers. Okay. Now, when we have integers that interact with each other, doing adding and subtracting, say you have something like 4 plus negative 3 subtract -1. We want to simplify these types of equations to make it easier for ourselves. So I'm going to just turn it into 4, subtract 3, plus 1. And that's going to give me a final answer of 4 subtract 3 is 1, plus 1 is 2. Okay, so make sure we're remembering our previous lessons about integers. And on this page, we are going to be completing page 152. We are not going to be touching at all 153. We're going to be doing numbers 1b, 2c, 4a and d, 5b and c, and 6a, c, e. All right, so 1b, 2c, 4ad, 5bc, and 6ace. That's on page 152. And then our last page that we'll be covering is going to be on the topic of translations. Translations is when we shift points across a graph, and we find new locations. But when we do this, we want to have a rule that's set up. So we don't just do it randomly. We want to understand how do we move from one to the next. Translations happen often. If you were to be, I like to think of it as if I were to be setting up a room. So say I have a room that me and my wife are planning on doing some redecorations in. Yeah. And we have some specific furniture that only fits in a specific way right now. So say we have a couch right here. We have a little coffee. This is a coffee table, couch. We have a corner couch right here, corner couch, and then we have our TV. Okay. Um, I'm going to be shifting these guys around and making it so it fits in a different orientation. And in some situations, it would be important for me to understand how far I'm moving them across and around. So you can have this come up in different ways, but it's a good thing for us to understand, especially when we get into more advanced stuff with not such basic figures like squares, like I have over here, rectangles. All right. Now, how do you differentiate between when the original position is and where the new position is? So, say I have a coffee table and I say, okay, well, this is actually the same coffee table. These are two the same. One's in the original position and one's in the image position, the not original one, the one I shifted now. How would I be able to tell the difference? Well, what I should do actually is I'm going to put a little prime number. That's like it looks like a little I. I'm going to put it CT with a little I. Another method you can do, so this is A, and then my image is A with a little I or prime symbol. You can also do a B or a B with like a little star, right? So either way, to sort of demonstrate that I'm using an image, and this is my image, the second part of it, I can either do a little prime symbol, which looks like a little I, or I can do a little star or asterisk if you like. And that sort of denotes, okay, this is not my original image. This is my original, this is my image, right? So here we want to start understanding how can we actually translate things and how can we describe these translations. So here I have a square and I have a second square. This second square is my image, so it's not my original one because I have a little dash right here. And what I'm saying is, okay, so here's my original point. This is point B on my image, and I have point B image. How do I know how far I went? Well, what I can do is I can count to my right and say, okay, well, I'm going to go from here to here. And what I want to do is start with my X and say, how many points did I go? 1, 2, 3, 4. I went 4 points to the right. And then I can say, well, I went 1 point down. So I went four units right, 1 unit down. Now, mathematically, we can start actually describing this in a little bit of a better term. For this question, I have point A and point A prime, or image prime, or image A. And what I could say is, well, I have a point here, and I have a point here. Now, notice how my arrow doesn't do it perfect justice, right? Arrows are only there to help me understand it a little bit more, but we can't just go off the arrow because you may follow the arrow and say, well, I go from here to here, but these are not the same points. This is on the right side of the square, so that means this other image should be on the right side of the square. And what I could say is, well, if I'm going to the right, one of the ways mathematically I could demonstrate that is I put a positive sign. I do a plus. The reason for that is because if you think of how any graph is oriented, typically they'll have, let me actually draw that out. If I have a graph right here, As I go upwards, I usually increase my numbers. As I go to my right, I usually increase my numbers. As I go down, I decrease my numbers. And as I go left, I decrease my numbers. This right here, this little point right here, it's called the point of origin. It is 1 or 0, 0. But mathematically speaking, whenever you go upwards, you'd be thinking of adding. Whenever you're going to the right, you're usually adding as well. Right? So these are lessons on translations. If you have any problems, please let me know. We do have a meeting at 10 o'clock for 1 hour where students should stop by and ask any questions that are especially challenging or just making sure that they're on the right track. Here are the questions you should be completing. This is on page 154 through 156. 154 through 156. And you will be doing the following numbers. We're going to do 1C, 2AC, 3B, 4A, 5, all 5. Number 6B. Oh, I guess you can't see this. Sorry. I'll show it to you after. 7, B and D. Number 8, B and D. And number 10A. All right. That's what I'd recommend. You can do different ones. You can do different ones if you want to, but those are the ones that I think sort of hit all the important points of our questions. Okay. I know it's a little bit of a longer video, but we're getting 3 lessons all in one, so please watch it till the end. Have a good day.